Okay, let's go through the 2019 Sec 1E end of year science paper for Christchurch. So which of the following, let's start from question 1, which of the following is a base quantity? Okay, the answer is C. And then circle C. Okay, this is actually a base quantity. All this can be found in your textbook. So there are total about, if not wrong, is 8 base quantities, and temperature is one of them. Okay, so just take note of it. Which of the following is not an SI unit? The answer is A. For Celsius, yes, is to measure temperature. Okay. However, the SI unit for temperature is actually kelvins. Okay, capital K. So very similar question 1 and 2, so take note of it. Which of the following is the order of magnitude of the diameter of Earth? So in your textbook, there's a page that talks about the whole spectrum from the smallest, which is about an atom, all the way to the universe kind of concept. One interesting thing is that they did mention that the radius of Earth, okay, is approximately about 6 times 10 to the power 6 meters. Hence, the diameter, which will be 2 times of the radius, it will actually be equals to 1.2, which will actually be equals to 12 times 10 to the power 6 meters. So if you press the calculator on this can actually be equals to 1.2 times 10 to the power 7 meters. So the answer would be C. Okay, next. Which of the following instruments is most suitable for measuring the height of a table? So the height of a table generally is about 75 cm to approximately about 90 cm. Okay, unless you get the Omni desk, which is going to be like 1.2 because those are standing desks. But generally, the height of a desk would be about the range of 75 all the way to about 90 meters. Okay, that's about IKEA height table, right? So because it is all less than 1 meter, the answer will be B. Now, why not C and D? It's really because C and D, the micrometer and vernier caliper, is really used to measure something a lot smaller. Okay, a ruler, we're assuming that's a small ruler, and hence it also doesn't work. Now, I'd like you to take note of it, that this question is really testing you about the range that the instrument can measure. Okay, so this question is on range. There will be another type of question that tests you on the precision of the instrument. So the precision type of instrument, that's something that we're going to see later on possibly. Okay, so the range and the precision will be different. Okay, next, question 4. So question 4 we're going to do next is, how can the gravitational field strength be calculated? Okay, so how to calculate gravitational field strength? We know that W equals to mg. So G is the one that we're going to find. So let's make it the formula. So W over m equals to G. So therefore, if I take W over m, which is actually weight over mass, so therefore answer is D. So it's about the formula now and knowing which one is the gravitational field strength. Next. The weight of a spacecraft on Earth is 2,250 newtons and on Mercury is 855 newtons. The gravitational field strength of Earth is 10 newton per kg. What's the gravitational field strength on Mercury? I think for this question, you have to take note that the mass of the spacecraft would be constant because mass doesn't change. It is the amount of matter in the object. So unless the spacecraft got disintegrated or broke down, the parts are went missing, otherwise the mass would be the same. So one simple way of doing it is actually to do this. Okay, type mg and W. Then this is for Earth. This is for Mercury. So the mass is the one I find, but I do know that Earth is G is 10, the weight is 2250. So because I have the weight, I have the G, I can find mass. To find mass is actually just W over G. Okay, it's just another manipulation of this formula over here. Okay, so the manipulation of this formula over here. So to find mass, I take W over G. So I'll get 225 kg over here. So as I mentioned, these two are the same. So this will be 225 kg. It's mentioned that the Mercury, the weight is actually 855 Newton. So based on these two, By what you realize that, sure, how to find G? G is actually taken W over M, so take this over this, you're going to get 3.8, okay, or 3.8. Okay, so take note D, which is, sorry, I shouldn't write DR, I should write 3.8 Newton per kg. Okay, next. Question 7. In a factory, cement was prepared in large amount before being used to form 3 types of equal dimension blocks. Okay, so hollow block, face block. Which of the following is true? So do they have the same density, mass, volume, or weight? Now, mass and weight is definitely related. So you can see because there are blocks that has been cut out, so definitely there are lesser mass, that means lesser weight. So B and D is out. Same volume. Now, you can see blocks are also being cut out, so it cannot be the same volume, therefore answer is A. Why is it A? It's really because if they are made out of the same material, okay, they're made out of the same material, their density will be the same. So just take note of this. Okay, this is actually one way to test whether if you know the density of gold, you can actually find out whether the object is really made of gold or not. Okay, just by checking the density. Next, question 8. The diagram shows a measuring cylinder that contains some water and 3 identical marbles. So take note, it's 3 identical marbles. The mass of one marble is 13.5 grams and its density is 2.7 grams per cm3. What's the volume of water? So let's first take a look at this. So normally when we read the measuring cylinder, we use what we call the lower meniscus. So which is this line over here. Hence the reading will be 40, 41, 42, 43 cm3. Okay, 43 cm3. So that's the volume of the water plus 3 marble. Okay. Now, to find the volume of water, I need to take 43 minus the volume of 3 marbles. So how to do that? They actually give you the mass, they give density. So actually I can use the density triangle. Okay, mass, density, volume. So to find the volume, you must take the mass divided by the density. So the mass is 13.5, the density is 2.7. Okay, so if you take this, you multiply, you realize that the volume would be 5.0 cm3. So if it's 5.0, now what I note is that if I take 43 minus 3 times of 5, I'm going to get my answer for the volume of water. And that means it's 43 minus 15, my answer will be 28 cm3. So answer will be C. Okay, next one. Question 9. The pendulum has a period of 2 seconds. A stopwatch started when the pendulum is vertical and is moving towards the left. Which diagram shows the position and the direction of pendulum 3.5 seconds later? So this is interesting, okay, because it's 3.5. So how exactly should we do this? Now let's think about the motion of a complete oscillation. So let's take it as the extreme motion, okay, take it as, let's say, the pendulum, right? If it starts here, the left extreme will be over here. Let's call this X. The right extreme will be over here, called Y. That means this is the maximum left position it will go, this is the maximum right position it will go. Okay, now how is it that there's one oscillation? So when you go into the left, so it goes like this, it will come back, then it will go to Y, and then it will come back. This is one complete oscillation. Now if you look at this, how many motions are there in total? Actually, of course, this is one smooth motion, but in general, you can actually see that there are 4 main arrows here. If it takes 2 seconds to make 4 of these arrows, okay, hence, we know that each of this arrow will actually be 0.5 seconds. Okay, because you take 2 divided by 4 is 0.5. Now, so if that's going to be the case, we can now think about it carefully now. So if I know that going one side is 0.5, so let's think through. This is the pendulum, like that, 0.5. Okay, X and Y. So I really just go and count. Coming back, 1.0. Going over here, 1.5. Coming back to the original position, 2.0. Going over here, 2.5. Coming back, 3.0. And then going over 3.5. Just imagine how the pendulum is swinging. So what I'm showing here is actually this motion of going over this side, going over this side, coming back, going over that side, and then coming back over here. Okay, so those of you who understand what I'm drawing over here, good. Those who don't understand, I think this diagram might serve you better. So the whole issue is you need to imagine how the pendulum is swinging, and then take it as each time it goes to one end or come back to the original position, okay, each of these little arrows is actually 0.5 seconds taken. So therefore, 3.5 seconds would actually be, let me count 3.5 means that it's at Y, means that it's coming back. So therefore the answer would be C. Okay, so you can see here 0.5 seconds later is at X, 1 second later it will be back at the original position. Okay, come back to Y, and blah 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 blah. So I know at 3.5 seconds later it will be at the right extreme. So when it is at Y, you realize the only possible direction that is moving is back to the center. Okay, therefore the answer is C. Next one, question 10, I think. Okay, last one. The cylinder contains liquids A, B, C, and objects X, Y, Z. The diagram shows the final three positions of the three objects. Which of the following statements are true? Now, I think the interesting thing here is you look at object X is floating in the middle of liquid A. So this whole diagram here is actually about density. Okay, it's all really about density over here. So to know their density, okay, you need to take note of this. Density are more dense will sink, less dense will float. Okay, this is the key concept we need you to know. Therefore, if you look at it, okay, let's start from the bottom. Z, okay, will be the densest because Z is all the way at the bottom. Then liquid C will be here because liquid C is at the second lowest at the bottom. Now you can see object Y has sunken to the bottom of liquid B. So actually object Y will be the next densest, followed by liquid B. Okay, then liquid A and object X is about the same. Okay, because you can see object X is floating inside liquid A, it's like sort of in the middle. So in terms of density wise, Z will be the densest, A and X will be the least dense. Okay, so this one here tells you which one is more dense, more dense, more dense, more dense. So Z is the most dense, A and X is the least dense. So which of the following statements are correct? X is as dense as liquid A, so this is correct, like what we have mentioned here because it's floating right in the middle. Y is denser than liquid B, so Y has sunk in liquid B, so yes, that's correct. Y is less dense than liquid C, so liquid C is over here, Y is floating on it, yes, that's correct. Z is as dense as liquid C, nope, Z is actually denser, so this is wrong, okay. Hence, the correct answer will be D, 8, 1, 2, and 3 only. So that's for the MCQ for 2019 paper.